All right, welcome everyone. Hello and welcome to today's Friday Transportation Seminar. I'm Jennifer Dill, Director of TREC, the Transportation Research and Education Center at Portland State University, and I will be introducing and moderating today's seminar. Our Friday Transportation Seminars have been a tradition since the year 2000. These seminars are usually held on the Portland State University's urban campus, located on the ancestral homelands of the Multnomah, Cathlamet, Clackamas, Tumwater, and Watlala bands of the Chinook, the Tualatin Kailapuya, and many other indigenous nations of the Columbia River. It is important that we acknowledge that we are here because of the sacrifices forced on the indigenous ancestors of this place. Remember the communities and honor their legacy, lives, and descendants. Due to COVID-19 pandemic, today's seminar is hosted fully online. And today, we're very pleased to have Jason Anderson and Sirisha Kothuri from Portland State presenting on systemic opportunities to improve older pedestrian safety. And I'll do an introduction of them now, but I also have a couple of other announcements after that, and then we'll start their presentation. So Dr. Jason Anderson is a research associate and adjunct professor at Portland State University. His expertise is in data analytics, particularly advanced statistical and econometric methods with an emphasis on transportation safety, transportation economics, travel behavior, mobility, big data, and policy-related applications. Dr. Anderson's research on transportation safety has helped advance fundamental knowledge on various factors that influence risk and severity of freight transportation-related crashes and the impacts of speed limit regulatory changes on driver behavior and safety. And as a fun fact, he is also an avid sports fan who does not miss a Sacramento Kings game or a NASCAR race. Dr. Sirisha Kothuri is a senior research associate in the Department of Civil and Environmental Engineering at Portland State. Her primary research interests are in the areas of multimodal traffic operations, bicycle and pedestrian counting, and safety. She is the research co-chair of Transportation Research Board's Pedestrians Committee and the Bicycle and Pedestrian Data Subcommittee, and also a member of the Traffic Signal Systems Committee. Just before we move on to the presentation, I want to put in some short plugs for a couple upcoming Friday seminars. We have Adonia Lugo from Antioch University, who's going to talk about stories from the Bike Equity Network in a couple of weeks. And then a couple of weeks following that, we have Madeline Brosen from UCLA talking about gendered harassment and women's travel needs. So we hope to see some of you at those events. And then particularly if you are a student at Portland State University, our student organization, the Students in Transportation Engineering and Planning, has several events coming up, some of which you don't need to be a student for. There's a couple open to all. And there's information at a website which we will put in the chat so you can access that more easily, and I encourage you to participate. And the last thing I need to remind everyone of, and some of you may be new to our seminars, you can expect our speakers to present for about 40 minutes, followed by question and answer. We will be receiving questions through the Q&A feature on your control panel, and we're going to ask those at the end of the presentation. If we do run out of time for all the questions, we do share them with the speakers afterwards. We have enabled closed captioning, but you must click on the closed captioning feature on your control panel to view them. And we are also recording today's webinar, and it will be available on our website later today, along with the presentation slides, if you want to share that with your colleagues or go back and watch again. And then again, if you are doing professional development, this is eligible for 1 hour of credit. So with that, I am going to pass it over to Jason Anderson.
Thanks, Jennifer. All right, let me just get this set up here. And there we are. So just as an also fun fact, I'm really excited that NASCAR season is starting now and we have the Daytona 500 this weekend. So thank you for the invite. I haven't done a Friday transportation seminar in a while, so I'm really excited to be able to talk to all of you about systemic opportunities to improve older pedestrian safety. This paper was presented at TRB and also accepted through the peer review process and is a byproduct of a larger project through the Oregon Department of Transportation that focuses not just on older pedestrians, but also on older drivers as well. And we've provided links for those at the end of the slides. So I'm going to go through the motivation of the study, and then I'll walk through the methods and then talk about a crash data analysis before I pass it off to Sirisha to finish up today's presentation. So before we get started, it's best to define what an older pedestrian or driver is. And that's defined as a person that's 65 years of age or older. In 2018, about 19% of all traffic fatalities were people within this age group, so 65 years of age or older. There was also a very large increase in older pedestrian fatalities from the period 2009 to 2018. And these national statistics, Oregon's trends follow these national stats. What's of concern, or a primary component of this, is that older pedestrians are more likely to sustain a serious injury and are more susceptible to crashes with motor vehicles when compared to other age cohorts. For potential reasons for this are slower walking speeds, situational demands, increased risk of falling, as well as visual and hearing degradation, which are all could be components of potential physical or cognitive decline in persons that are older than the age of 65. So due to these increases in fatalities as well as serious injuries, the special rule for older drivers and pedestrians, which is within the FAST Act, was started. This special rule for older drivers and pedestrians is for states to develop strategies to address such an issue if such an issue is present within the state. But identifying where and what, or if there's an issue, and then what infrastructure improvements need to be made within a region or a municipality is quite a challenge. And then the success of this implementation depends on both the location as well as the conditions within that location. So the premise behind the ODOT project, as well as this paper, was to develop a framework for Oregon specifically that can identify if there is an issue within this age cohort, and then what are some potential strategies to address potential issues. So that leads me into the objectives of this work and the project. And the first was to identify overrepresentations for older pedestrians' serious injury crashes. This was done through a comprehensive crash data analysis, which I will go over in a few minutes. The next was to generate a comprehensive list of potential countermeasures. This included both countermeasures at the national level as well as countermeasures from the Oregon Department of Transportation Arts program. Then we were to hold a workshop with stakeholders and experts throughout the state, which also included specific representatives from certain regions based on some of the crash analysis or crash data analysis that I will talk about. Then we wanted to summarize these workshop findings and then have stakeholders and experts, the participants at the workshop, rank order some potential solutions. And that'll be the focus of what Sirisha talks to you about at the latter part of today's presentation. So the methods to accomplish this was, again, to use Oregon crash data. And at the time of the study, our most recent year of crash data was 2016. So we looked at the most recent 4 years due to recent concerns of temporal instability. Then we identified important variables through a machine learning approach, random forest. Then we compared crash trends for older pedestrians with those crash trends of other age cohorts. Then we generated that list of potential countermeasures. And then we took all of this information with us to the workshop and presented all of these findings to the workshop participants. So I'm going to spend the next few minutes going over the crash data analysis. Oh, sorry. Large images, delay on slides. So the first part of the crash data analysis was to simply understand, based on the raw frequencies within the crash data, what was happening with older pedestrians throughout the state of Oregon. And so this slide summarizes some of those key findings from purely the raw frequencies of the crash data. So I'm just going to briefly kind of go through here and highlight the most occurring based on the crash characteristic. So for time of day, the majority of older pedestrian crashes were happening in the late afternoon into the evening, so 3 p.m. to 6 p.m. and 6 p.m. to 9 p.m. Most of the older pedestrian serious injury crashes occurred in urban areas, which was not surprising, particularly on arterials, minor arterials, and major collectors. Weather condition and lighting condition, these were expected, being that however you disaggregate the data for the type of analysis that you're doing, clear conditions and daylight conditions make up a very large proportion. Day of the week was fairly evenly split across all days, considering with Friday having the most older pedestrian serious injury crashes. Intersections accounted for more than half. And then dry roadway surface conditions are very similar to lighting and weather conditions, and they're overrepresented regardless of how you disaggregate the crash data. And then we also splitted the age groups into age groups that were above 65 years old. And those were fairly split across, with the fewest number happening with persons aged 85 years or older. And then we looked at some specific pedestrian action, pedestrian location, as well as pedestrian level crash cause. For those, the pedestrian action, for the majority of crashes, they were either crossing between intersections, crossing at an intersection that didn't have a traffic signal or did have a traffic signal, and then or no action was being taken by the pedestrian. In terms of pedestrian location, the pedestrian was located at an intersection inside the crosswalk for the majority of crashes, as well as in the road, but not at an intersection. And then for pedestrian level crash cause, almost half of the older pedestrian serious injury crashes, the older pedestrian was not at fault. Of the cases where there was a pedestrian level crash cause coded, the motorist, non-motorist being illegally in the roadway or not being visible, for example, dark or non-reflective clothing were the majority of pedestrian level crash causes. So based on this crash data analysis, we took the most occurring frequencies, and that was some of the information that was given to the stakeholders and experts at the workshop. The next thing we did was we compared the crash trends for older pedestrians to other age cohorts. And so first we just looked at the overall trend for the 4 years of crash data that we analyzed. And what we saw that was there was a fairly, if we were to draw a trend line for either age group other than 16 to 24 years, we would see that there's a slight increase over this 4-year period. To further that comparison, we conducted a series of z-tests of proportions to 3 different age groups. So we had the older pedestrian age group, persons age 65 years or older, an age group of 16 to 24, an age group of 25 to 44, and an age group of 45 to 64. So these age groups were based on NHTSA publications where they break down crash characteristics by age group, where these age groups are most commonly used. So the results that are on this slide are proportions in which the older pedestrian serious injury crashes were statistically significantly higher compared to the other age groups. So the results from this were crashes that occurred at a driveway or alley access. Older pedestrian proportions were higher compared to the 16 to 24 age group and the 25 to 44 age group. And then also crashes that occurred at an intersection, the proportion was higher for older pedestrians compared to the 25 through 64 age groups. In terms of weather, older pedestrians had a higher proportion when the weather was snowy compared to the 45 to 64 age group. Lighting conditions, as I mentioned, daylight makes up a lot of observations. This is true for each age group. Still, older pedestrians had a higher proportion compared to all age groups considered. And then also at dawn, older pedestrians had a higher proportion compared to the 25 through 64 age groups. In terms of pedestrian action, location, and cause, if the pedestrian was crossing at an intersection, older pedestrians were significantly different, the proportion, compared to the 25 to 44 age group. And then in terms of location, at the intersection, not in the roadway, was significantly different compared to all age groups. And then at the intersection, in the roadway, but not in the crosswalk, was significantly different and higher compared to the 16 to 24 age group. And then the final difference in which the proportion for older pedestrians was higher was not being at fault. And that was significantly higher compared to the 16 to 24 age group and the 45 to 64 age group. So that was the crash data analysis, and those key findings were summarized and presented to the stakeholders and experts invited to the workshop. The next step was to identify important variables, and we did this through a random forest. The idea here was not to replace the machine learning approach with traditional safety models, rather to complement traditional safety models. And in this case, the ability to assess the importance of specific variables in predicting fatal or serious injury crashes. We assess this based on two metrics. These are the two common metrics from a random forest approach. The first is an accuracy-based method or importance. And this is based on the prediction accuracy of a specific outcome due to a specific variable. So if there is a loss in accuracy due to the exclusion of some explanatory variable, then that variable is deemed more important than others. The other is a Gini-based accuracy or a Gini coefficient. You'll hear various terms for this. And this is based on how a variable contributes to the homogeny of tree nodes and leaves. The idea here is that the degree of probability of a specific variable being wrongly classified when chosen randomly. So the more homogeny, the less likely that is. There we go. And so here are two figures that are the output of or part of the outputs from the random forest analysis. Apologies for the text being a little small, but I'll summarize the ones considered on the next slide. And so on the left, we have a set of indicator variables given to the random forest algorithm. And we have the most important variables based on the mean decrease in accuracy. And then on the right side, we have a plot based on the mean decrease in the Gini coefficient or the Gini index. Now, there are several methods on where we should draw a threshold here. Some base it on a percentage, some base it on a number. For the purpose of our study, we simply wanted the 5 most important variables from both metrics to use those to present to the stakeholders and experts at the workshop. And so in taking the 5 most important from the left plot and then the 5 most important from the right plot, I want to summarize those with this table right here. So the most important variables based on this random forest analysis in terms of accuracy were crashes that occurred in the dark in which no street lights were present, crashes that occurred at an intersection, crashes in which the pedestrian was at an intersection and inside the crosswalk, crashes that occurred during cloudy conditions, and then crashes that occurred during daylight. For the top important variables based on the Gini index, there were a couple similarities, but also a handful of differences. So the most important based on this metric were urban principal arterials, with second also being an urban roadway classification, minor arterials. Again, we see that dark with no streetlights was also an important variable using this metric, as were cloudy weather conditions. And then the 5th most important based on the Gini index was the pedestrian being illegally in the roadway. So these results too were results that were bundled with the results from the crash data analysis in terms of raw frequencies and the z-test of proportions to be given to the workshop participants. As part of the project as a whole, we also conducted a population-based crash rate. The idea behind the population-based crash rate was to identify specific areas in Oregon as to invite, if there is an overrepresentation in older pedestrian or older driver serious injury crashes for the workshop, was to reach out to representatives from that region or that area of Oregon to attend the workshop. And so this map here simply shows the various counties throughout Oregon in which the population-based crash rate was based by county. And then the, they're not triangles, the diamonds with the pedestrian in them represent older pedestrian serious injury crashes. Because the map is zoomed out, there are many coincident points on this map, but we can easily tell from here that the majority of the crashes are happening in our urban areas. So being that this is a population-based crash rate, we also wanted to look at just spatially where are these crashes occurring in terms of population. We can sort of infer that from the previous plot based on knowledge of where the major metropolitan areas are within the state of Oregon. This map provides population by county. And so the darker the gray, the higher the population, the lighter the gray, the lower the population. And once again, we see that the majority of these older pedestrian serious injury crashes are happening in areas with higher population, most notably our major urban and metropolitan areas. And I do want to note again that due to the scale of the map, that many of these points are coincident points. So through the population-based crash rate, we identified several counties in which when compared to the other age cohorts that we did for the z-test of proportions, that the number of older pedestrian serious injury crashes per 100,000 total population was higher. Those counties included Curry, Hood River, Morrow, Umatilla, and Washington. We also wanted to focus on Lincoln, although not the highest, it was also very high relative to the other age cohorts. So for this, we use these results to reach out to representatives from these areas of Oregon to attend the workshop and take part in the workshop. So that wraps up my portion of today's presentation. I will hand it over to Sirisha to go into more detail about the workshop itself.
Thanks, Jason. Hello, everyone. So I'm going to be talking about the workshop, and the objective of this particular workshop was to bring together stakeholders and experts who were responsible for policy and design guidance as pertaining to improving older driver and older pedestrian safety. So this presentation is part of a larger study that we conducted for ODOT, and I put the link in the chat a few minutes ago. And so that overall study also looked at older driver safety in addition to older pedestrian safety. But in this presentation, we are going to be focusing on older pedestrian safety. So the idea was that we bring these experts together, we present them with the results of our crash data analysis, our countermeasure selection, and then have them identify potential solutions and opportunities for improving policies and procedures at their agency. So in consultation with the TAC coordinator and the other members of the TAC, we came up with a list of stakeholders to invite to the workshop. And in addition to the ODOT personnel, we also included members from counties that were overrepresented in older pedestrian crashes that Jason talked about a few minutes ago. We also invited representatives from agencies that were tasked with improving older driver safety, like AAA and AARP, and also members from the League of Oregon Counties. So this workshop took place in Salem, Oregon in November of 2019. And as you can see on the right there, we had about 18 of the stakeholders attend. And the research team presented the overview of the project, what the objectives were, the findings from the crash data, and the countermeasure selection. And then we also designed and conducted a set of 3 activities with the participants in order to get their feedback. And finally, as Jason mentioned earlier, we rank ordered the 3 proposed solutions. Next slide, please. Yeah. Okay. So, so the first activity in the workshop was to document patterns in older driver and pedestrian crash data. So we had 2 breakout groups, one pertaining to the older driver issues and the older pedestrian issues. So this again is focused on the older pedestrian issues. So in this task, the participants were asked to review the crash data sheets that we provided them, looking at all the plots that we showed you a few minutes ago, and then to document any of the patterns that they thought were notable. And once they did that independently on their own, we asked the participants to discuss these trends in the group where they were situated, and then as a group come up with the most important trends and overrepresentations, and then record that on the response sheet. I do want to mention that we divided the workshop participants into 4 groups, and each of these groups was carefully chosen to offer a mix of perspectives at each table or within each group. So in terms of the findings or unexpected crash trends, what participants identified most was pedestrians crossing between intersections, daylight, and urban areas. Again, these are all not very surprising. These were shown as important factors in the crash analysis. And then since we also asked them to identify the potential cause for these crash trends, so for crossing between intersections, they thought that pedestrians jaywalking, crossing without a signal could be potential causes. And another cause that they speculated was that it was harder for older pedestrians to estimate speeds and gaps between traffic, and this could be another cause for crashes. In urban areas, they speculated that crossing parallel to the main line could be a potential cause of crashes. And this was potentially related to crashes between vehicles making those left turns or right turns from the major street and then getting into conflicts with these pedestrians. Then our second activity was to understand solutions for the patterns that they noted in activity 1. And again, they were instructed to identify these solutions and then share among the group, and as a group come up with some potential solutions. To aid them in their activity, we provided them with a list of countermeasures divided by specific categories that were identified from the literature. So what did we find? There were a number of solutions that were proposed, and these have been divided into the different categories, as you can see here. One of the top ones that was selected was looking at access management and driveway spacing, because this was one of the top contributors for crashes. So the participants thought that reducing driveway density or removing driveways from T intersections could lead to lower crashes. Another big one was crosswalk spacing. They thought that providing adequate crosswalk spacing was necessary, and also to just increase the number of crossing opportunities by providing marked crosswalks or enhanced crosswalks, which means crosswalks enhanced with particular crossing treatments like RRFBs or LED lights and things like that. And then also providing crossings at safe and consistent intervals so that pedestrians have an opportunity to cross. Lighting and visibility at intersections was also considered important. The participants thought that improved lighting both at intersections and at mid-walk crossings could help with reducing pedestrian crashes, and also this would increase the driver expectation of encountering pedestrians. And then finally, crossing visibility is another important one. Some participants thought that we need to be focusing on rural arterials because this could be places where older pedestrians are trying to cross. There is overall low volume, and so driver expectation of encountering pedestrians is low. And then also providing lit signage and flashing signals could help with increasing the overall visibility, and then also providing reflective striping could help. And then we moved on to the third activity, and in this activity, we wanted participants to, as a group, discuss and identify possible systemic actions that an agency could take to improve older pedestrian safety. And again, they were asked to do this by themselves, discuss in a group, and offer up potential solutions. And once they provided these solutions, we as a research team took them and then ranked them for presenting it to them again later so that they could rank order them. Okay, so this slide shows the solutions that they came up with and the priorities. So they were asked to vote once for the top priority, second, and third priorities, and these potential solutions were categorized based on the different categories that you saw. So intersections was one category, roadway design, roadway lighting, education, and others. So within the intersection category, the most important top priority as chosen by participants was increased use of protected left turns, so eliminating those permissive movements, which is particularly problematic since drivers are looking for gaps in the opposing traffic and not necessarily looking at pedestrians as they seek to make that left turn. Another big one was eliminating driveway access in close proximity to intersections, and then basically providing better lighting at intersections to increase pedestrian visibility. The other sort of priorities that were also ranked highly were shortening the crossing distance. So this relates to decreasing the exposure of pedestrians while they're in the crosswalk by providing either curb extensions or medians, and lowering speeds overall, and which in general could improve pedestrian safety. And then in terms of second priority, again, some of these ones that were chosen as the top priority were also chosen, that is the increased use of protected left turns. But the other ones that also came up on top were to provide those crossings at regular intervals and eliminating free flow turns and right turn slip lanes. And then finally, for the third priority, we had pretty much the similar ones that were chosen as the top and second. So there were certain themes, as you can see, that really emerged from the workshop. There were a handful of treatments that practitioners considered were really important in increasing overall older pedestrian safety. In terms of education, the practitioners thought that educating both drivers and pedestrians on crosswalk use could help, and then providing better transit routes and stops could also help, because pedestrian volumes are generally high around transit stops, and people are crossing the streets to access these transit services. And so improving those stops and the area around the stops could help increase pedestrian safety, and then reducing barriers to obtaining rights. Okay, so once we had these recommendations from the workshops and also the crash analysis and the countermeasure selection, we wanted to put all these together and come up with some recommendations for ODOT to implement. And so we identified three top systemic treatments. One was improving pedestrian visibility and illumination, then treatments for left turns and shortening crossing distances. You will notice that there were other options that ranked pretty highly in terms of driveway access and lowering speeds. We did not recommend that in this particular report, although they are really important, because we wanted to focus on the systemic treatments that are low cost. That was the objective of the report. But our recommendation at the end was to also focus on lowering the speeds overall, and looking at geometric and other design changes that would also help address older pedestrian safety. And one point that I would like to mention is that although these treatments are offered as treatments for improving older pedestrian safety, they will benefit all road users. So they will also improve safety for other pedestrians as well. And I will go through each of them in detail. So the first recommendation was to improve pedestrian visibility and illumination. And based on our crash analysis, we saw that 1/3 of the older pedestrian crashes occurred at dark, where there were no streetlights, at dusk or dawn, and these are periods where there is no ambient lighting. And this particular countermeasure was voted as a top priority by the workshop participants. And so we thought, in order to improve overall pedestrian visibility and illumination, what agencies could do is to improve lighting at intersections and near crossing locations by installing one option is to install these rectangular rapid flashing beacons, as you see on the top right there. Or you could also install LED mounted pedestrian crossing signs, etc. And then these could serve to improve pedestrian visibility. And we know from the literature that increased visibility is correlated with reduction in crashes, and it has been shown to reduce crashes by up to 13%. The second recommendation was related to left turns. We saw from our crash analysis that left turns accounted for 19% of the crashes, and increasing the use of protected left turns can improve safety, because when you have permissive movements, drivers are focused on looking at gaps in the opposing traffic and not really looking at pedestrians that may be crossing. And so in addition to improving older pedestrian safety, the use of protected left turns can also improve older driver safety because it can reduce their cognitive load as well. We also recommended that they could use the flashing yellow arrow indication for right turns in addition to using the protected left turns that we have shown in other research has improved pedestrian safety. And if agencies do end up using the flashing yellow indication for left turns, we recommend that they use a pedestrian-friendly logic that inhibits the flashing yellow arrow indication from coming up when a pedestrian is likely to cross. New York and other agencies have also sought to slow down the left turning vehicles by using wedges and center lines and other treatments as shown here. And so that could be an option. And finally, using signal timing treatments like protected pedestrian faces and leading pedestrian intervals can also improve pedestrian safety. So separating pedestrians with these signal timing treatments can reduce crashes by up to 13%, but this does increase overall delay for other users. And then the other recommendation that we made was to consider shortening crossing distances. And older pedestrians tend to walk more slowly when they're in the roadway. And so this increases the exposure, the time that they spend while crossing. And so by using treatments to shorten crossing distances, this could limit their exposure time. And you can do this by adding pedestrian islands, curb extensions, which again reduce the crossing distance, and then also providing raised crosswalks and road diets. A review of the literature has shown that pedestrian islands have reduced crashes by up to 14%, and raised crosswalks and road diets have decreased crashes by up to 46%. So in conclusion, older pedestrian safety is a really important issue. Nationwide, we have seen an increasing trend in older pedestrian crashes, both nationwide and here in Oregon. Older pedestrians, because of their characteristics, are at highest risk for serious injury crashes. And in this study, we tried to highlight this issue. We have developed a data-driven framework for agencies to get at some systemic recommendations and to improve older pedestrian safety. And in the future, as I mentioned, we do recommend that agencies consider treatments to address speeding, because that is a huge contributing factor to overall pedestrian safety. And we know that the risk of a serious injury or fatality increases as speed of the vehicle increases. And in the future, using additional data sources like exposure data or land use data can also provide additional insight on older pedestrian crash behavior. With that, I'd like to thank ODOT for funding this research. And here are a couple of links. The first one is the report, which the study was based on. And I think the link is in the chat. And then there will be a journal article on the pedestrian portion of the study that will be coming out soon in Transportation Research Record. And with that, we'd be happy to take any questions.
Great, thank you so much, Sirisha and Jason. We have several questions in the Q&A box, and I encourage our audience to add more. I am, though, going to take my moderator prerogative and kick us off with a broader question. And one reason, and I asked you to do this seminar because I really like this idea of combining both sort of the quantitative analysis of data with this workshop. And so I want to ask you, sir, what do you think the benefits of having that workshop were? And in particular, maybe frame it as what did you as the researchers learn from that? And what do you think maybe the participants learned from it? So what's the value, and that leads to perhaps also, would you recommend that other agencies or researchers take that approach?
Jason, do you want to start and I can add on?
Go for it. Sure, I'll start. So I thought it was very beneficial. So I do a lot of work with data, theoretical methods, but don't really bridge the gap very often to how can these findings and these methods be used in practice. And so the workshop for me was really helpful in that regard, in being able to bridge that gap using these analytical methods and then taking these results to the traffic safety engineers, the people that help do the design guidelines, and getting their input and them using that was really helpful for me specifically. And then it's also been really helpful, that framework, and I've proposed it to actually other areas of ODOT in other scenarios because I thought it was so beneficial on both sides, both the researcher as well as the ODOT personnel.
Yeah, I agree. And I think a lot of times we as researchers tend to come up with a lot of, countermeasures and solutions that, as Jason referred, are based exclusively on data. But as a practitioner, or there are different considerations that they have to balance, right, in terms of cost and practicality and budget and resources available that we are not always, as researchers thinking of. And so, as Jason said, it's really nice to bridge that gap to sort of identify the low-hanging fruit, if you will, of like what are the low-cost improvements that we can make immediately today, and then what are some of the more longer-term changes that we need to make in the system to improve pedestrian safety.
Great. Okay, so we have a number of questions here, and I'm gonna, I may paraphrase some of them, so apologies to those of you who wrote them. There's a first question coming about data, and Paul Mackey points out that it's also important when we're thinking Vision Zero to think about the whole transportation network and think about falls that happen on the sidewalk. And so I know that your data source doesn't include those types of injuries that didn't involve a motor vehicle. And so I'm wondering, maybe Sirisha, if you could just briefly sort of explain the different data sources that are available when we're looking at older pedestrians, particularly injuries in our transportation network, and how that might limit, or what data would we need to look at falls?
Yeah, that's an interesting question. I do agree we need to look at them, but unfortunately, as we know, the data is not always there. We do know also that pedestrian crashes in general are underreported. So that's another problem that we have with the crash data. But for incidents where there is not a crash involving a motor vehicle, I'm not really sure if it gets reported at all. We might have to look at the hospital data, or EMS or trauma data, and those are because of the privacy regulations surrounding those data sets. They are really hard to come by, and there have been some efforts, especially in North Carolina and other agencies, to try and combine those hospital data sets with our traditional crash data, because we know crash data suffers from underreporting, so that we can get a true measure of what's happening out there in our system. But by and large, most of the states don't do that yet. And so I agree with Paul that it's really important, but we don't have widespread access to that data just yet.
Great. And then another data related question. In the data set, did you have data on sort of the vehicle involved, and in particular cars versus SUVs or larger vehicles? And were you able to look at the role of the vehicle?
Jason, do you want to take that?
Yeah, I got it. So in the report, the ODOT report that we've mentioned a handful of times now, we did match the pedestrian crashes with the corresponding vehicle and look specifically at vehicle movements and vehicle action. We did not look at vehicle type in that regard. That is something that we could consider for future work and could be put on that future work slides. But we were able to match the pedestrian crashes with the vehicle crashes, and then from that be able to tell what the vehicle movement was or the vehicle action was based on the crash data.
Great. And then you looked at crashes by population. Did you also look at the age distribution of the population in those counties to see how that might have correlated with crashes or injuries?
Yeah, so in terms of relating or correlating that to number of crashes, that was not part of the analysis. But in terms of identifying the percentage of the population that was within the age cohorts that we focused on, that information was inherently gathered and looked at as part of the population-based crash rate analysis. For the report, however, our only output from that process was the population-based crash rate. But we did look at some of the distributions as it was inherently part of the process.
Great. One question on here is a little more of a clarification, and it's one that I had too. So Jason, you listed a crash location as at an intersection, but not in the roadway. So where did that occur? Was it on the sidewalk or what?
I get these ODOT crash questions quite a bit. So the definition in the ODOT crash manual is not at intersection, or at intersection, but not in the roadway. And so getting an exact answer is sometimes very difficult. And so sometimes we're left to speculate a little bit about what exactly that means. Some of the responses that I've received are that it's not within the striping, so not within the roadway in terms of the vehicle path. So it's outside of that. It could also include being on the sidewalk as well. Unfortunately, because I haven't received a better answer, I can't provide a better answer than that.
Okay, so in other words, some of it could be a person stepped off the curb, but they're maybe not past the white stripe or whatever.
That's one of the definitions that I've received, yes.
Okay, and maybe this also gets at part of the issue with the data that we use for analyses like this is maybe inconsistencies in how things are coded and defined, and I'm assuming that makes your work a little challenging. So let's see. Oh, new questions coming in. Let's see. In your data, did left turns made from a one-way street pose the same problem with left turns from two-way streets? So, and did you even have enough data to look at that type of thing?
Yeah, so the only one-way street piece of information in Oregon crash data is actually in the traffic control device variable. And so we didn't match up anything with pedestrian and the vehicle crashes, anything outside of what the vehicle was doing at the time.
Okay, great. A question, Kay, a couple questions sort of related to the options that you considered. And one question about perhaps considering spacing of intersections, but also do you think sidewalk design is part of a solution?
Yeah, I think so. And in terms of sidewalk design, we could also look at how the curb itself interfaces with the sidewalk, and then extending those curb, providing those curb extensions and using that curb extensions maybe as sort of a part of the sidewalk and reducing that crossing distance would help, I think.
Excellent. And then there's been a little bit of a follow-up. That question about at an intersection, but not in a roadway. One participant wondered if it might be at a driveway, but weren't driveways coded differently? Like that's a different code in the data?
So the driveway or alley access is coded based on the character of the road, so intersection, segment, those sort of things. The pedestrian action or location is just not in roadway. There's really no differentiating between in driveway or just not in roadway. So it kind of goes back to my response to the previous question.
Okay, great, thank you. All right, so and then a question sort of about the workshop participants, and you mentioned that there were ODOT folks, but also others. And how many of the people are there people in these workshops who specifically focus on older adult traffic safety, or are they just sort of broader traffic safety experts?
I think we did request people to participate who were focused on older pedestrian safety. We'll have to go back and look at the specific titles of the participants. I think it's in the report at the end. But I don't know if you remember, Jason, but I think as I mentioned before, it's older pedestrian safety is, I think, a subset of the larger question of improving overall pedestrian safety. And so a lot of the participants present while they're interested in older pedestrian safety, but we're also interested in the overall question of like improving general pedestrian safety, I guess. But I'll have to go back and look at the specifics. Yeah. I don't know, Jason, if you remember.
I don't. I want to say I recall one of the TAC members has a lot of work in the older pedestrian and older driver realm. That's I'd have to look at the list as well.
I would also think that the workshop is an opportunity for people who maybe haven't focused on that specifically to take some time focusing and thinking about this particular group. And to me, that would be one of the benefits of this workshop approach. There's a question here. I'm going to just read it because this one I don't think I'm good at paraphrasing. So from Nick, 30.4% of non-motorists illegally in the roadway makes me think aging pedestrians take on too much of the culpability for being in the public right-of-way. 45.5% of no cause associated makes me think motorists should be held more responsible than what the data can explain. How can we obtain more data on what is happening on the motorist side during these crashes?
So I'll kind of answer that, just I guess build on like what's in the ODOT data already. So for a lot of the crashes that we were matched the pedestrian to the motor, there wasn't as much driver related information with those as the vehicle to vehicle crashes that I can recall. And so just filling in some of those data characteristics would fill some of that gap. It allow us to get some driver action at the time, not just the vehicle movement or what the vehicle was doing, but driver action, possibly driver error. So those parts of the data characteristics. And then outside of the Oregon crash data, I saw this in one of the other comments about observational studies. That could be an opportunity in collecting the driver behavior in those types of incidents, or a driving simulator, which Sirisha, I think you've done projects using a driving simulator, could also be a way to record kind of what the driver is doing and perceiving the situation when that happens.
Great, thank you. And thank you for wrapping in one of those other questions I wasn't able to get to. So we are quickly approaching our end time. So I'm going to ask Jason to unshare his screen, and I am going to share mine and wrap up here. First of all, I really want to thank Jason and Sirisha for presenting this. I had wanted to see your presentation at TRB and that wasn't possible, so I was happy to see it here. I want to remind all of our audience, stay connected. If you do not subscribe to our newsletter, please do, so you can hear about other events such as this. And then also after the seminar ends, you'll have an opportunity to do a very brief survey about today's event. We really do appreciate your feedback. And with that, we're going to end our seminar. So thank you, everyone.